Hi everyone, and welcome back after half term. I suspect lots of you, like me, are struggling to get back into the routine of a week at homeschool. It feels like ages that we've been at homeschool, I know. I just wanted to start really quickly by just saying how impressed I've been with all of you. I noticed when I was looking at the quiz questions from last week, how honest lots of you have been about what you're finding hard, what you're not finding hard, and what areas you know you've still got to work on. It's so impressive that in year 5, you're able to be honest about what you, not just honest in fact, but you're able to identify what you need to get better at. It's such an important skill, not just for maths, but for life in general. So well done, pat on the back if you've been able to be really, really reflective and say, this is what I'm finding hard, or this is what I know I need to practice. An even bigger pat on the back if you're doing something about it, whether that's messaging me, whether that's asking your parents, looking on something like BBC Bite Size, or you might even find a lesson on the Oak National Academy to get more ideas to practice your skills. So I know a few of you have messaged asking for more help. Fantastic, brilliant. Anyway, what we're going to do today, I think lots of you have just said that a few of the things we've gone over in the last few weeks are just a little bit murky. You're just not quite totally sure on them. So I think it'd be really useful today to just have a bit of a recap and a revision of some of those things to make sure that we're really, really confident with them before we move on further. So what I want to just go over today, again, is converting fractions, simplifying fractions, and then lots of you talked about a bit of a muddle about the methods. So we're just going to really break that down into essentially the 2 ways that we might deal with calculating fractions, or 2.5. I'm going to call it 2.5 ways. Okay, so let's start with converting. Really, the only fractions we're going to be converting are likely to be mixed and improper. There wouldn't really be a need to convert a proper fraction to something else. And if it's a proper fraction, it's not going to be a mixed fraction. So we're really only going to convert improper to mixed. So I've got let's do bars of chocolate. I've got 2 bars of chocolate here. You can see my whole bars, and I just happen to have split them into quarters because I know that my fraction is a quarter. So if we were using this, I've got 1 and 2 quarters. So I've got 1 whole bar of chocolate, and I've got 2 quarters of a bar of chocolate. That's how much chocolate I have as a mixed, check that pen out, as a mixed fraction. I could write this as an improper fraction. That means that there is no whole number there. So I would get rid of, where's my pen gone? Oh no, don't freeze now. Let's just carry on regardless. I'll get rid of my whole number. There's lots of ways you might do this, but what we know is that this whole is 4/4. It's 4 quarters. So really what I'm doing is saying I've got 1 whole and I'm timesing it by the 4 parts that I know this whole is made up of. There we go. So I'm going to have 1, 2, 3, 4, 1 times 4 fourths plus the 2/4 I've got up here. So if we were making a shortcut, a bit of a cheat, and we know we've got to be careful with cheats because sometimes we can misunderstand them. But if we were making a bit of a cheat, we might say the way to convert from a mixed fraction to an improper fraction is to multiply the whole number by the number of parts and then add it to the numerator. I'll say that again. To times the whole number by the number of parts you have in your denominator, and then add that to the numerator. So in this case, I've got 1 whole. It's split into 4 parts. So I do 1 times 4. That's 1, 2, 3, 4. Then I add my 2. 1, 2. So I have 6/4. So if I'm converting, I would then make this 6/4, like that. If I'm going in the opposite direction, if I'm going from improper to mixed, then I'm going to ask myself, what is my denominator? My denominator is 4. So I need to remove 4 from this 6. I've got six bits of chocolate, and I know there are 4 bits of chocolate in a bar. So if I take 1, 2, 3, 4 away, that's 1 bar and 2 bits. I just realized, I don't know if you can see my fingers. I think you can. So sometimes drawing out is helpful. Otherwise, you can use those tricks. But just remember that 1 whole is, in this case, it's 4/4. If that denominator were different, if that denominator were 5, let's say, 1 whole would be 5/5. If that denominator were 8, then 1 whole would be, I'm going to draw this really badly, it's probably not even, but let's just pretend they're even, 8/8. So whatever that 1 whole is, it represents that number of parts. Hopefully that clears that up a little bit. You might want to pause and rewind a few times just to really get your head clear around that. The whole is going to be 8/8. If the denominator is 4, it's going to be 4/4. If the denominator is 29, then a whole is going to be 29/29. If a denominator is 120, then 1 whole is going to be 120/120ths. I'm not going to carry on because it becomes a bit of a tongue twister. But once you get that really clear in your head, then I think you'll find it easier to start converting, because I know that that 1 whole is 8/8 plus those 2 8s that I already have. So 8 plus 2 makes 10. So 1 and 2 8s would be 10/8. And then I use the inverse when I'm going this direction, and I subtract. Okay, simplifying. So we have a fraction, we want to get it in its lowest form. Simplify just means that we want to get it into the lowest possible fraction, because lower fractions, smaller fractions, are easier, simpler to deal with. There's 2 ways to approach, or there's 2 questions to ask yourself when you're simplifying fractions. Are both numbers even? Is the numerator and the denominator even? If they are, the chances are that you can just keep halving and halving and halving and halving and halving and halving until you can't halve any further. If they're not, it gets a little bit trickier. And you need to ask yourself, are both of these numbers in the 3 times table, the 5 times table? If you're unlucky, it might be the 7 or the 9 or the 8s even. But more often than not, particularly when we're talking about primary maths, we're going to see them in our 3 and our 5 times table. Most teachers aren't as horrible as to do lots of questions involving 7s and 9s. So those are the questions to ask. Once you've done that, it's just about dividing. And we're dividing the numerator and the denominator. So in 9/12, I know that both of those numbers are in the 3 times table. So I'm going to divide 9 by 3. I'm going to divide 12 by 3. So 9 divided by 3 is going to be 3. 12 divided by 3 is going to be 4. So I know that 9/12 is the same as 3/4. So when we're simplifying, it is about the easiest way to simplify is even numbers and just keep halving. Apart from that, you're looking at the times tables and you're finding a times table that both the numerator and the denominator are both in. Okay, again, you might want to pause that, have a little think about it. You might want to just sit down, get your head around it, do some examples, have a practice. Remember, this is about you taking responsibility. So if this is something that you've been struggling with, don't just carry on watching the rest of this clip. Stop, get some scrap paper out, write some fractions, see if you can simplify them down. You might even want to see if you can explain it to a parent, a carer, maybe a granny via Zoom or Skype or something. Because explaining it, putting it into words and telling someone else how to do it is going to make you more confident. So there's lots of different ways that you can make sure you are clear on how you convert and how you simplify. But please make sure that you're confident in that before you go to the next part of this video. Right. The calculations themselves. And from the looks of the quiz, lots of you are doing fine on the calculations, but I think you've just got yourselves in a muddle, because I know in the last lessons we looked at all the different ways that our characters got to the calculations. Actually, what they were doing is finding the most efficient way. And they were sometimes finding shortcuts. Realistically, we've got two methods. We can turn everything into an improper fraction, or we can convert and simplify. And convert, when I say converting this time, I mean changing the fractions so that, or the two fractions, so they both have the same denominator. So we've got two options. If we're going to turn them into improper fractions, that means we're going to change them from mixed into improper. So my 1.5, or 1 2/4, sorry, 1 whole and 2/4, I'm going to make this all into quarters. So I've got 1, 2, 3, 4. That's 1 times 4 plus my 2. So I know that actually I would change this to 6/4, and I would get rid of that. That's not what I wanted to do at all. There we go. So I could change that to 6/4, and then I would look at this one. I've got 1, 2, 3. I've got 1 whole, sorry, and all this is in eighths. Oh, look, this is a bit trickier. So let's just quickly make my top eighths as well. I know it's not even. Lots of you probably shouting at the telly there. So 1, 2, 3, 4, 5, 6, 7, 8. 1 times 8, 8. Plus I've got my 3, 9, 10, 11. So I'm going to change that to 11 eighths, and I'm going to get rid of my 1. So now I've got 6/4 plus 11 eighths. Doesn't matter that it's plus. You might be doing subtraction. The same method works, different calculation. Can I subtract 11 eighths from 6/4? Hopefully you're all shouting no, because these are fourths and these are eighths. But it's a simple enough job to convert them. Voila, I've now turned 6/4 into eighths. But actually, have I still got 6 eighths? I haven't, have I? Because that 1/4 is now 2 eighths. So 2, 4, 6, 8, 10, 12. My 6 eighths is now, my 6/4 is now 12 eighths. Well, now I've got them both as improper fractions with the same denominator. I can do my, in this case, it's addition. And all I need to work out is 12 plus 11. 12 plus 11 is 23. I know my denominator is 8. And then I'm just going to put my bar in there. I can, if I want to then simplify, I can work out how many eighths are in 23. How many wholes am I going to have? I do that by using my 8 times table. 1 8 is 8. 2 eighths is 16. 3 eighths is 24. Well, I haven't got 24, so I know it's going to be 2 wholes. So let's just quickly pop this in. So that equals 2 wholes. 2 wholes, that's 8, 16, 23. Remove those 16. It's going to leave me with 7. 7 eighths. Oh, it's a little bit messy here now, I know. I haven't finished totally yet. I've got to see, can I simplify 7 eighths down? I can't halve 7. That's not going to work. So I go through my times tables. It's got to be a number smaller than 8. 7's not in the 5 times table, nor is 8. It's not in the 3 times table, neither of them in the 3 times table. I've already done the 2's, and the 1's not going to help me here. So the simplest way I can have that or express this fraction is 2 7/8. So the other way I could have done it, let's just get rid of all of that and go back to our original question. Don't forget you can rewind if you need to. So my original question was 1 and, oh, what am I doing there? 1 2/4 plus 1 3/8. I could have not turned them to improper fractions and just converted or simplified. So in that case, I would leave my 2 whole 1s there. And in fact, I might have even just removed my 1s over here and just said, right, remember, in a minute, we're going to add those together. Let's just pop an add symbol in there. Oh, that's not an add symbol. Remind us, there were 2 1 wholes. There's my 1 whole. Whoop, wrong button. There's my 1 whole. Over there, let's just put it over there. There's my 1 whole. Let's just put it over there. And I'll add those 2 1s together. Hopefully you can all manage to add 2 1s together. If not, grab a bit of pen and paper and practice. And now I'm left with my fraction. I know my answer is going to have 1 plus 1, which hopefully you've figured out is a 2. And now I've got 2/4 and 3/8. Exactly the same thing applies. I can't add 4ths and 8ths without doing some converting. So I'm going to turn my 4ths into 8ths. And now I've got, let's just change that into 8ths. I no longer have 2 8ths. I've got 1, 2, 3, 4. I've got 4 8ths. So I'm doing 4 8ths plus 3 8ths. Well, my 8 remains the same. Oh, can I be fancy and just copy and paste? No, I can't. I can. There you go. So I know my denominator stays the same. 4 plus 3 is what? It's 7. So I get my 7 8ths. So I know that it could be 2 7/8. So in this method, I didn't add in my whole numbers. Instead, I put them aside. I dealt with my calculation using those whole numbers first, and then adding up, or you could do subtracting, my fractions. Let's have a look at that with subtraction, because it is slightly trickier with subtraction. Can anyone think why it might be slightly, let me just go back to this page. Why might it be slightly trickier with subtraction? And don't just say because subtraction's horrible. Yeah, it might be trickier with subtraction if you have to exchange. If your fraction is smaller than this fraction, but you've got whole numbers. So let's just put those whole numbers back for a moment and imagine it was a subtraction. In fact, let's just change it to a subtraction. If, let's do it, I'm just going to play around with this for a second. Sorry, ignore. If I had that calculation, well, I couldn't take my whole numbers out of the equation. I've got to do some changing because 3 8ths doesn't have enough for me to remove 4 8ths. So I would need to make that improper. So subtraction is trickier because you've got to look at the question and say, have I got enough of something to take it away without pulling into that whole number? Hopefully I haven't lost you in that last moment of explanations. If I have, bear with me. Hopefully it's going to make sense. Subtraction. We've still got the same 2 methods we started with. We can turn everything into an improper fraction and just deal with it as an improper fraction. The reason we don't always do that is because sometimes that might be a slower way of dealing with things. There's nothing wrong with it. It might just be slower than doing the conversion, particularly if you're good at your times tables. By good, I mean quick. Okay, so let's turn these all into improper fractions. We've got 3 2/5. Where's it gone? 3 and 2/5. What is that the same as in fifths? I realise my ball's going all over the place here. Let's make it a bit tidier. Well, the way I'm going to solve this, we talked about this earlier, is I've got to think I've got three whole, but each of those wholes is in 5 parts. So let me just get my wholes for a second. 1, and it's in 5 parts. This is going to be a bit messy, but bear with me. 1, 2. The unequalest whole parts you've ever seen. That's one whole in 5 equal parts. Well, I've got 3 of those. Oh, that was a bad idea. Can I copy and paste it? Okay. There we go. I've got 3 of those. So 3 times 5. What's 3 times 5? Well, it's 15. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I know that in my 3, I've got 15 fifths. But I've also got here 2 more. So it's not 15, it's 15 plus 2. 16, 17. So I've got 17 fifths. So 3 and 2/5 is the same as 17 fifths. Let's just move all of that out of the way for a second. And now we've got 1 and 3/10. 1 and 3/10. What's that going to be the same as in tenths? Again, my presentation's all over the place, but you'll be neater in your books. You're not having to deal with a computer. Okay, so 1 times 10 is 10. Plus my 3 means that here I've got 13 tenths. So if I now put this into my sum, what I could say is I'm doing let's just give ourselves a bit more space. 17 fifths subtract 13 tenths. Oh, what am I doing? There we go. Equals. Okay, now I can't do this still because one of my denominators is tenths and one of my denominators is fifths. Well, I know that. Let's just grab one of my fifths over here. Doesn't matter which one, but I know that if I've got a whole split into 5 equal parts and I want to split it into 10 equal parts, I'm going to have double the number of parts. So if I'm going to change 5 into 10, I'm doubling it. I'm doubling 5 to make 10. If I'm doubling 5 to make 10, I've also got to double 17. Doubling 17. So I know double 7 is 14. I know double 10 is 20. Adding those two together and I get 34. So now I've taken my 3 and 2/5 and I've converted that into 17 fifths. That's an improper fraction. I've taken my 1 and 3/10 and I've converted that into 13 tenths, an improper fraction. And then I had to convert my 17 fifths into tenths. And I did that by doubling it. And now I've got 34 tenths. Take away 13 tenths. Well, I know that my denominator is still going to be tenths. So all I've got to do now is 34 take away 13. Just like any subtraction, I'm going to start with my units, my ones. 4 take away 3 is 1. 3 take away, or 30 take away 10 is 20. So I know that I've got 21. So now I've got 21 tenths. So can I simplify this? Well, 10 is an even number, but 21 isn't. So I can't just halve it. So let's go through some other questions. Which times table is 10 and 21? What one are they both in? They're not both in the 3 times table. They're not in the 4 because they're not even. They're not in the 5. They're not in the 6. They're not in the 7. They're not in the 8. They're not in the 9. So actually, I can't simplify 21 tenths down unless I do what? Brilliant. Hopefully some of you said it's still an improper fraction. I could simplify it by making it a mixed fraction. So I've got 21 tenths. How many wholes can I make from 21 tenths? 10 tenths would give me 1 whole. 20 tenths would give me 2 wholes. So I know if I take 20 away, 20 tenths, that gives me 2 wholes. And then I would have 1 tenth left over. Can I simplify 1 tenth down any further? Well, actually, in this case, I can't, because I know I can't divide 1 by anything to make it smaller. So 2 and 1 tenth would be the simplest way of this fraction, dealing with this fraction. So just to recap, here was the question that we started with. That is not what I meant to do. Here was the question that we started with. And the way we dealt with this one was we converted both fractions into improper fractions. Once we did that, we changed the denominators to be the same, and then we did the subtraction. Once we did the subtraction, we had to get it out of being improper back to mixed in order to simplify. That was one way of dealing with this. We could have dealt with it in isolation. Let's go to a whole new page because it's going to get messy. We could have instead looked at it in its parts. So over here, I've got 3 2/5. I could have said, actually, let's just take that 3 and put it over here. I'll come back to it in a second. Over here, I've got 1 3/10. And let's just take this 1 and put it over here. And I know that in a moment, I'm going to have to do 3 take away 1 equals. Okay. I'm going to keep those bits over there. And I'll come back to that in a second. And now I've got 2/5 take away 3/10 equals. Well, I've still got to do my conversions. So I've got fifths. I need to make it tenths. I'm doubling 10, doubling 2 is 4. So now I've got 4 tenths. Take away 3 tenths leaves me with 1 tenth. Don't forget, I've got my 3 take away 1. 3 take away 1 is 2. So I'm going to bring that 2 over here. So I've got 2 and 1/10. And again, I look at this. Can I simplify 2 and 1/10 down? I can't, because I can't divide 1 by anything. So whenever we're dealing with addition or subtraction of fractions, you've got two approaches, basically. Turn them to improper fractions, or separate out the whole numbers and the fractions. Where it will get tricky with subtraction is if you need to exchange from the whole number in order to do your subtraction. What I'm going to do, I'm going to, on today's PDF, have a couple of subtraction and addition questions. They're going to start with ones that are just fractions, proper fractions, with the denominators the same. Then they're going to move to fractions where you've got to change the denominator, and then to some mixed ones. I really want you to be honest about this. Go through them, try the different questions, and see where you get stuck. If you're still finding that you're struggling with one aspect, see if you can spot and work out what it is you're struggling with. Are you finding that whenever you convert the denominators, something goes wrong? Are you finding that you keep forgetting to simplify? Because once you've worked out where your mistake is, then together with your parents, with myself, with your brain, we can start to fix this. So can you, I'm not going to put the answers up today. Can you go and download the sheet? You can do it on a piece of paper, work through those questions, see if you can solve them. If you're getting in a pickle, try and identify what part is making you worry, what part is making you get stressed out or think that this is complicated. Try and identify, pin down on that part, and then let me know. All right, guys, I will see you tomorrow.